No, you won't be able to keep it. So, there are two types of electrochemical cells, guys. We have a voltaic cell, which is similar to a battery. Okay? Oh, it says batter? Well, add the Y there, okay? So it's not, a cookie batter or anything like that. And then number two, the second type, guys, is called an electrolytic cell. That's similar to an alternator in your car. Okay, very important. When the alternator goes, all your electronics go. That happened to me about a month or so ago. I'm driving down the road, all my dashboard went clear. The RPM meter, the speedometer all went to zero. Power steering was lost. I'm trying to drive through traffic on Jefferson Road. It was not fun times, all right? But anyway, similarities between the two guys, they both involve redox reactions. They're chemical reactions which involve the flow of electrons. Again, we know that. That's review. They both involve the flow of electrical energy or current, which is measured in volts. All right, it's kind of a little bit of physics application, kind of tying the two together. They both have two electrodes, which are conductive surfaces where oxidation or reduction occurs. One is called the anode. The other is called the cathode. Oxidation or reduction occurs in each half cell. Okay, so you'll see what I mean as we kind of get into the picture of it, and we'll talk all about the cells that are involved. I guarantee you guys you will be asked questions about this. You'll have a picture on your Regents exam, or you will have to draw a picture of it and explain and show what's happening in each half cell. All right, so this is something that's very important that we're able to do. All right, so how you remember the difference between the cathode and the anode, guys, or what's happening at those, red cat and ox. So like Leo the Lion says grr, with cells, it's red cat and ox. Reduction happens at the cathode, all right? Oxidation happens at the anode. So remember, we're gaining electrons at the cathode. So if you think about it, we're gaining electrons, you should be bulking up, so to say. You'll see what I mean as we get into these cells. Oxidation, you're losing. The metal is going to lose those electrons, so it's going to start to go away. It's going to start to disappear. You should be jotting this down because this is not in your notes. This is super important to make sure you get this in your notes. Electrons flow through the wire, guys, from the anode to the cathode. So think about what's happening. We go from anode to the cathode because we're losing those electrons. They're going away from where they're being lost. For reduction to happen, those ions will then travel over to the cathode, and that's where they start to bulk up. They start to kind of deposit on the cathode. So you'll see what I mean as we go through. So it's very important that when you speak about them, that you're thinking it through, that you can make sure that you know what you're talking about. We good? Can I go on? I don't know. So, voltaic cells, guys, these are cells that happen spontaneously. They convert chemical energy into electrical energy or electric current. These are what batteries are doing, okay? So I'm sure we've all seen a battery that's kind of like past its prime, and it starts to kind of start corroding, and it starts coming out, right? That's when you want to make sure, one, you're not really touching that stuff because it can harm you, and that you stop using that battery. So, I mean, you can touch it, but if you leave it on your skin and stuff, over time it can start to corrode and, cause some problems. So, this is spontaneous. What does spontaneous mean? Do you have to add any extra energy to it? No, it happens on its own. Okay, so it happens on its own, which is why batteries, once you plug them in, or you ever leave like batteries in like your junk drawer and like the ends come in contact, the positive and negative end, and then they're hot. If you never seen that or had that happen, it can happen. So where one will flow from one to the other, okay, and then so you want to make sure that they're not touching it, otherwise you'll ruin the batteries without even using them. Yeah.
I once swallowed a battery.
All right, so guys, the cathode. Here's how you identify the cathode from the anode. The cathode is less active. So you're going to see the two metals. You have to go use table J. Okay? The cathode is the less active of the two metals on table J. They spontaneously attract electrons to the positive electrode in a voltaic cell. And this is again where the electrode where the reduction occurs. Remember, red cat. Yes? When everybody turns it in.
What?
Yep. Yep. I still have 2 or 3 students who haven't turned it in.
I don't think they're going to.
So the anode, guys, if the cathode is the less active, the anode is going to be the more active of the two metals. Again, using table J. It will spontaneously lose electrons to the cathode. All right, this is the negative end of the electrode in a voltaic cell. It's where oxidation is occurring. Remember, anox, anode, oxidation. We know the pieces already of what's happening, what reduction means, what oxidation means. You just had a quiz on it. So now we're going to put it all together in a closed system. That's your voltaic cell. So, guys, an example. There's a couple different ones. There's a wet cell battery, and then there's the dry cell. The wet cell is like your car battery. There's actually liquid inside your car battery. It's a form of lead storage battery. Okay? You had to make one? Okay? It consists of a lead anode and a lead oxide cathode. Both electrodes are immersed in a sulfuric acid solution. This is why they can be very dangerous. Why, when you have a car battery, when you change yours out, you can actually take it back to wherever you bought your new one, and they will give you some money back for a disposal fee. Okay, very in-depth processes to dispose of them properly.
So why would they give you money to dispose of it?
So that they will recharge it. And they can take the components out of it and then recycle it. So they're going to recycle it and stuff and make more money because car batteries are like $100 a piece. So you'll get a few dollars back, but then they can take the components and reuse it. Both electrodes, guys, we said, okay, the advantage, it's a process that is readily reversible. This is why the alternator, this is what your alternator in your car is doing. The disadvantage is they're very heavy and they are somewhat dangerous. If they were to start leaking, all right, it's got that sulfuric acid. Is that a strong acid? You bet. Okay, so if it starts leaking, it can corrode your car and it can get everywhere and it can be kind of a mess. So there's some advantages and disadvantages to both sides. The big one is that it's reversible. If you had a dry cell battery in your car, you'd have to change it out a whole lot more. Eventually, we know that, yeah, do they last forever? No. Okay, think about what's happening. You've got those nodes, and one is being reduced. One is being oxidized, so it's losing mass. Eventually, guys, it's going to run out. It's not going to have any more electrons to give to the cathode. Guys, example number 2, like I said, is the dry cell. These are the type of batteries that are in your radio, your remote control. All right, radio. You guys don't even use a radio anymore. All right. But it's not one that has batteries, like a dry cell battery. You don't have a boombox that's, rocking on your shoulder as you're walking down the street like they used to. Right? Say anything, you hold it. No, you never seen that movie? All right. So, guys, these have a carbon or graphite cathode that's surrounded by a moist electrolyte paste, usually zinc anode. This is why, guys, with those batteries, like AA's, AAA's and stuff, over time, the older they are, then that's when stuff can start to leak out, that kind of liquid paste, and then it will become crusty, and then you shouldn't use it anymore, right? Okay. Now, one big piece. What?
That's what happens when you're...
Exactly. Yep. It starts to leak out. So, the last piece, guys, that these ones have, these voltaic cells, they have a salt bridge. Okay. What's a salt? Right? Any ionic compound. Okay. But this bridge is very important, guys. Without this pathway, no ions, no electrons would flow. It provides that path, and it prevents the buildup of charge. Okay? If you were to take, like I said... All right, so flip to this page in your notes. According to table J, lead is more active. That means this is going to be our anode. So once you identify that, guys, you want to identify your two nodes. So the anode and the cathode. Okay, that they do. Now, what's happening, guys, at the anode? Okay, which means what's happening? What?
Oxidation.
Anox, red cath. So this is where oxidation is taking place. Cathode is where reduction is taking place. So question 1 asks us, which direction will it spontaneously flow? Which way is it going to go? Is it going to go to the right or to the left?
To the right.
It's going to go this way, guys. It's going to flow to the right. Okay? Now, through the wire, it's not going to go through the solutions. Okay? Bless you. It would flow this way. Okay? It's going to flow from the left to the right, going through the wires. Okay? So you will be asked questions like this. You don't have to label these cells, these electrochemical cells, these voltaic ones. I will guarantee you that there's going to be a question about them, whether it's a short answer or a multiple choice on your Regents exam. Think about it. Which one's gaining electrons, guys?
Cathode.
Yeah, the cathode, right? So the cathode's going to be negative. The anode's going to be your positive. If you take a look back here at our notes, okay, the anode is the negative one. Just think about your basic chemistry. What's the anode doing? So, that's why, again, you can see, guys, it's very easy to get these two mixed up. Why is it negative? Because it's going to be giving those up. So it's going from our negative to our positive because the electrons that it's giving away are being attracted to it. Okay, so the flow's right. The anode is going to be negative. The cathode is your positive one to keep that flow of electrons to go. Okay, so we did that up above.
Gaining electrons?
Point out, with these voltaic cells, also, guys, they're called galvanic cells. Both mean the same thing. Okay, so it's not that the electrons are staying on your silver electrode. They're in solution. Okay, when we make these batteries on Wednesday in lab and you guys are going to test some things out, you got to have a solution, right? Because where do ions exist? In solution. All right, in solution. So the electrons, they're coming through, they're flowing out of here where the oxidation's happening, up through the wire, here into solution, because they want to get to where the positive charges are. Okay, the other positive charges. All right, the salt bridge allows ions to continue through, so there's your cell. All right, but they're flowing through that. That's why the cathode never becomes negative, is because those electrons are flowing through it and they keep going back and forth. All right, they're flowing through the cathode. It's a pathway that allows those to flow. Other type of cell, guys, is electrolytic cells. What do you think is involved with these? A battery, right? Electricity, because these are non-spontaneous. They need some extra jolt to kind of get it going. These are cells, guys, that use electrical energy to force a non-spontaneous chemical reaction to occur. This is the process for electrolysis or electroplating. All right, electrolysis or electroplating. Electrolysis, one example of that is you can break up water into its two components. What are the two components of water? Hydrogen and oxygen. So you can produce hydrogen gas this way and oxygen gas by splitting it up. But you have to add a lot of power to it. All right, I would do this for you, but the apparatus that I inherited and found isn't working. All right. This is your alternator in your car. It keeps the car battery replenished. So like we said, you can use kind of electrolytic and wet cells together because the alternator allows it to become that electrolytic where it's supplying it to let it go in that reversible reaction in your car battery. All right? Keeps replenishing it. Now, guys, this is where it gets a little bit different. In an electrolytic cell, the cathode is the electrode where the electrons are sent. It is the negative electrode. So this is the opposite of what we were just discussing. Okay, it's the opposite of a voltaic cell, which is why you can see you get confused very easily. All right? The electrode where reduction occurs. So it's still red cat, but the negative positive piece becomes flipped. Okay? So this is why it makes sense when we were thinking about a voltaic cell. Oh, shouldn't it be the other way around? Yeah, with the electro one, the electrolytic cell, that's where it's the opposite, where it makes the one that makes sense. The voltaic is the one that's a little bit different, and that's the one you're going to definitely see on your Regents exam is the voltaic. The anode in an electrolytic cell is the electrode where electrons are drawn away from. That makes it the positive electrode. It's, again, the opposite of a voltaic cell. So if you know one, know the other one is the opposite. Again, oxidation, anox. Notice, there is no salt bridge here. This is a forced chemical reaction. You will always see a power source hooked up to an electrolytic cell, which drives the forced reaction. So this one does not have a bridge. Okay? The battery, there's some electrical source that forces this one to happen. I know. Okay? Using our notes will come in handy. Galvanic or voltaic? Let's start there. And this is going to be a resource, guys. It's going to help you out tremendously to kind of get it down what's happening. Let's start with the galvanic one first. The flow of electrons, is it spontaneous or is it forced? All right, this one is spontaneous.
Are they the same? Galvanic and voltaic.
Right, both those names are the same. Yep. You'll hear, if you hear galvanic or voltaic, they mean the same thing. It's the spontaneous one. Electrolytic, they are forced. Okay? So, the positive electrode. This is where looking back in your notes, guys. All right? Which one's the positive one? With voltaic? The cathode is the positive electrode here in the galvanic, which means the electrolytic, which one's going to be positive? The anode will be the positive one. Okay, they're opposite. So then the negative electrode in a galvanic cell is going to be the anode. And electrolytic, it's going to be the cathode. Okay? Now, the direction of the electron flow. There's our flows. Galvanic anode to cathode. All right. Electrolytic is cathode to anode. Now, where's the reduction half cell, guys? Is that going to be different for the two cells? No, right? Because it's still what? Reduction is red cat. Oh my gosh. Oh wow. Red cat, guys. So the reduction half cell is still the cathode. Okay. For both. And oxidation is still at the anode. It's just the flow of electrons. That's the piece that makes it opposite. The basics are still the same. It's the flow of electrons where they get switched up. Now, no, guys, fuel cells are galvanic cells for which the reactions are continuously supplied, like a hydrogen fuel cell, right, for like renewable energy.